Download this code from codegive.com, link in the description below. Next.js 15 Tutorial 49, Server-Side Rendering, SSR, Deep Dive. This tutorial provides a comprehensive guide to server-side rendering, SSR, in Next.js 15. We'll cover the fundamental concepts, benefits, drawbacks, and practical implementation with code examples. You'll learn how to leverage SSR for improved SEO, faster first contentful paint, FCP, and dynamic content rendering. What is server-side rendering, SSR? Server-side rendering, SSR, is a rendering technique where the HTML for a web page is generated on the server before being sent to the client's browser. This contrasts with client-side rendering, CSR, where the browser receives a minimal HTML shell and the application logic, typically JavaScript, is responsible for building the DOM and rendering the content. Key differences between SSR and CSR*. Feature server-side rendering, SSR, client-side rendering, CSR. Rendering location server client, browser. Initial load faster FCP, slower time to interactive, TTI, slower FCP, faster TTI, potentially after hydration. SEO friendliness highly SEO friendly less SEO friendly, requires workarounds. Code complexity potentially more complex potentially simpler. Server load higher lower. JavaScript requirement can work with JS disabled initially requires JavaScript to render content. Benefits of SSR*. Improved SEO *. Search engine crawlers can easily index fully rendered HTML content, leading to better search rankings. This is because crawlers can see the content without executing JavaScript. Faster first contentful paint, FCP. The browser receives fully rendered HTML, which means users see content on the screen much faster. This improves the perceived performance and user experience, especially on slow network connections or devices. Better social sharing. Social media bots can easily scrape content and generate previews from the server-rendered HTML. This ensures accurate previews when sharing links. Dynamic content generation. SSR allows you to fetch and render dynamic content from databases or APIs on the server, ensuring that the content is always up to date. Accessibility. A server-rendered page has semantic HTML immediately, improving accessibility for users with screen readers or other assistive technologies. Drawbacks of SSR*. Increased server load. The server needs to render HTML for each request, potentially increasing server load and costs. More complex development. SSR often requires more complex code and infrastructure compared to CSR. You need to handle data fetching, error handling, and server-side logic. Slower time to interactive, TTI. While FCP is faster, the time to interactive, TTI, might be slower because the browser still needs to download, parse, and execute JavaScript to make the page fully interactive, hydration. Potential for initial render blocking. If your server-side data fetching takes a long time, it can block the initial render, negatively impacting FCP. Optimize your data fetching and consider streaming techniques. Next.js SSR implementation with get server-side props. Next.js simplifies SSR through the get server-side props function. This function is executed on the server side for every request to a page, allowing you to fetch data and pass it as props to your component. Steps to implement SSR in Next.js*. 1. Create a next.js project*. If you don't already have one. 2. Create a page*. Create a page file in the pages directory, example pages/index.js. 3. Implement get server side props *. Add the get server side props function to your page component. This function must be async. 4. Fetch data * inside get server side props. Fetch the data you need for your page from an API, database, or any other data source. 5. Return props * return an object from get server side props with a props key. The value of the props key will be passed as props to your page component. Code example *. Explanation *. Homepage, data, *. This is a standard React functional component that receives data as a prop. Get server side props, *. This function is unique to next.js and is executed on the server. Await fetch, *. This fetches data from the specified API endpoint. You'll replace this with your actual data fetching logic. Const data equals await rest.json, * parses the JSON response from the API. Return props, data * this returns an object with a props key. The data key within props is passed as a prop to the homepage component. Error handling * the if, rest.ok, block is crucial for handling potential errors from the API. It checks the HTTP status code of the response. If the request fails, example 404, 500, it returns an object with an empty data array as a fallback. This prevents the entire page from crashing if the data fetch fails. You might also want to log the error for debugging purposes. Running the example * 1. Install dependencies * if you haven't already, install the dependencies. 2. Run the development server * 3. Open the page * open your browser and navigate to http://localhost 3000. You should see the data fetched from the API rendered on the page. Important considerations and best practices *. Data fetching optimization * caching * implement caching strategies to reduce the load on your data source. Use techniques like HTTP caching * leverage HTTP headers like cache control in your API responses to instruct browsers and CDNs to cache the data. Server-side caching * implement server-side caching using tools like Redis or MEMC8 to cache frequently accessed data. Next.js also provides built-in data caching mechanisms in newer versions. Data fetching libraries * use libraries like SWR or React Query to simplify data fetching, caching, and error handling. These libraries provide features like automatic retries, revalidation, and optimistic updates. Debouncing/throttling * when fetching data based on user input, consider debouncing or throttling the requests to avoid overwhelming the server. Parallel data fetching * if possible, fetch independent data sets in parallel to reduce the overall loading time. Error handling * implement robust error handling to gracefully handle API failures and other errors. Provide informative error messages to the user. Log errors for debugging. Security * sanitize data * sanitize user input to prevent cross-site scripting, XSS, attacks. Secure API keys * store API keys securely and avoid exposing them directly in your client-side code. Use environment variables or secrets management tools. Validate input * validate data received from the API to prevent unexpected errors or security vulnerabilities. Performance * optimize data fetching * use efficient data fetching techniques to minimize the time it takes to fetch data from the server. Code splitting * split your code into smaller chunks to reduce the initial load time. Image optimization. Optimize images by compressing them and using appropriate formats. Use next.js's built-in image optimization features. Avoid blocking rendering. Minimize any long-running operations in get server-side props that could block the rendering process. Consider using streaming rendering to render parts of the page as data becomes available. Measure performance. Use tools like Google PageSpeed Insights and Web Page Test to measure the performance of your application and identify areas for improvement. Dynamic routes. If you're using dynamic routes, you'll also need to implement get static paths in addition to get server-side props. Get static paths defines the paths that should be statically generated at build time. This is important for SEO and performance with dynamic routes. For example, if you have a blog with URLs like /blog/slug, get static paths would generate the HTML for each specific blog post. Then, get server-side props would be executed at request time to fetch the actual content for that specific slug. If your data changes extremely frequently, or you have a vast number of dynamic routes, you might consider a completely server-side rendering approach with just get server-side props and omitting get static paths. However, this means every route will be server-side rendered for every request, potentially adding significant server load. Streaming in next.js 14+, advanced. Next.js 14 and later introduces streaming, allowing you to send HTML chunks to the client as they become available. This further improves FCP and perceived performance. Streaming works particularly well with data fetching that might take longer. To use streaming, ensure you're using the app directory, not the pages directory, and server components. Here's a basic example, using the app directory. Explanation *app/page.js*. This is a server component, indicated by its location within the app directory. *suspense*. The suspense component allows you to display a fallback UI, example loading, while the slow component is fetching data. Crucially, the rest of the page can render before the slow component completes its data fetching. *fetched data*. Simulates a slow API request with a 2-second delay. *slow component*. Fetches the data and renders the list of items. With streaming and suspense, the browser receives the initial HTML for the H1 element and the suspense S fallback UI immediately. Then, after the slow component finishes fetching data, the browser receives the HTML for the list of items. This greatly improves the perceived performance of the page. When to use SSR versus static site generation, SSG, versus client-side rendering, CSR. *SSR*. Use SSR when you need. *excellent SEO. *fast FCP and need to render initial content quickly. *dynamic content that changes frequently. *data that is user-specific, example authenticated user data. For example, personalized dashboards or user profiles. While you can use SSG with user-specific data with appropriate caching, SSR often makes it easier. *SSG*. Use SSG when your content is relatively static or changes infrequently, example blog posts, documentation. You want excellent performance and scalability. You don't need user-specific data on the initial render. *CSR*. Use CSR when SEO is not a primary concern. You have highly interactive applications, example single-page applications. You can tolerate a slower initial load time. The majority of your content is highly dynamic and requires client-side interactions. Conclusion *. Server-side rendering, SSR, is a powerful technique that can significantly improve the SEO, performance, and user experience of your next.js applications. By understanding the benefits and drawbacks of SSR and implementing it effectively using get server-side props, or streaming with app directory server components, you can build high-quality web applications that are both search engine friendly and performant. Remember to optimize your data fetching, handle errors gracefully, and prioritize security best practices. Choose the rendering strategy, SSR, SSG, CSR, or a hybrid approach, that best suits the specific needs of your application. Experiment and test to find the optimal configuration for your project.